Second part. Theory. Experiments of thought. Introduction. The enigma of consciousness. A blank slate is the best map for tracing a new path. Thoughts form more easily with nothing else to watch. So Galileo stared at a bare wall, rehearsing in his mind what he had seen. The rooms he had entered, the people visited. Frick was right. Consciousness depends entirely on the brain. If the brain ceases to function, nothing is left. Not us, and not the world around. When Copernicus had lost his cerebrum, the universe had lost his point of view, and his own universe had vanished to a point. Not all of the brain's vast continents matter. Only a few privileged lands. The trembling painter had lost as many nerve cells as Copernicus, yet he was fully conscious. So the cerebrum matters, but not the cerebellum. How neurons are connected, not just how many of them. The cerebellum is like a great archipelago, millions of islands separated by an impassable sea. If every isolated island, each with its own village, were submerged by a cataclysmic sea wave, who would know or notice? But if Europe, the cerebrum of the world, had been wiped out, all would have been lost. Why was it so? Wasn't the cerebellum just as populated as the cerebrum? He had learned too that the nerves that originate in the eye and reach the cerebrum are not essential for consciousness. The blind painter's eyesight was dead, but not his mind sight. In his blindness he could still imagine colors and shapes and dream of them. He could project bright images on the walls of his darkened mind. Neither was there any need for the nerves that leave the cerebrum and steer our every deed. His friend M lay mute and paralyzed, inert as an ancient rock, but was as conscious as his visitors were. Not even the intricate nerve loops that leave the cerebrum, perform complicated calculations and bring back the results are necessary for consciousness, though without them consciousness may lose her faithful slaves, those that relay messages to their empress and interpret her every wish, and those that store and retrieve her memories. And he thought of the poetess and the gamba player. Then he remembered Ishmael and Teresa. They had taught him that consciousness can be divided if the connections linking the two halves of the cerebrum are split, or if the front is separated from the back, whether by the icy water that Salerno had poured, or by the hot vapors that rose from the womb. He thought of the wretched girl on the wheel, what he had learned from her. When the doctor poured camphor oil onto her brain, he had learned that consciousness can be lost as well when too many nerve cells are active together. And from the Frenchman asleep near the stove, he had learned that when the waves that stir the ocean of the cortex are too deep and uniform, consciousness is drowned. So consciousness depends not just on certain parts of the cerebrum, but those parts must be functioning in the proper way. But then, what is special about those parts of the cerebrum and the way they function when we are awake or dreaming? How can it be that the sweeping universe of consciousness is due to a fistful of jelly inside a skull, and only when it quivers of quick intertwining waves? Galileo was searching for answers, but Frick was nowhere to be seen. Instead, a stranger entered the room. His name was Alturi, or so it sounded to Galileo. He addressed Galileo so: "You've learned your facts about the brain and consciousness, or so I shall presume. But now tell me, how much wiser are you for all that? Remember, the world is full of facts and short of logic." Then, with no hesitation, Alturi said, "I know what's troubling you. Just speak the question, as simply and clearly as you can. One goes quite far with logic and imagination," he added, and seemed confident in the extreme. For a while, Galileo sat staring motionless at the blank wall. But Galileo was not one to turn his back to a challenge. There were really two problems, Galileo had concluded. They could be called the first and the second problem of consciousness. So he stood up, facing Alturi, and went on to state them. Here was the first problem of consciousness. What determines if consciousness is present and where it lives? This was the problem Galileo was struggling with right now. Why does consciousness live in the brain and not in the liver? Why, for that matter, only in certain parts of the brain, the cerebrum and not the cerebellum? The world contains many material things, galaxies and stars and planets, mountains, rocks and sand, oceans, lakes and rivers, oaks and wheat and daffodils, towers, mills, shares and clocks, limbs and trunks, lungs and hearts, ears and eyes. But consciousness seemed to live only inside a bright point in every person's head. There was a second problem too, one that should be tackled perhaps only after the first one was solved. Here was the second problem. What determines the specific way consciousness is? What determines the visual quality of sight or the auditory quality of sound? There must be something about the organization of certain parts of the cerebrum that makes each of them contribute specific qualities to consciousness, said Galileo. But precisely what aspect of neural organization is responsible for shapes to look the way they do, and different from the way colors appear, or pain feels? Alturi smiled faintly. Trust me, there is really just one problem. If you knew what determines whether consciousness is present where it lives, why there is one inside my head, one inside yours, and none in a heap of sand, you would not be far from knowing what determines its quality. Why it feels this way or that way, why it feels purple or painful. One problem, said Alturi, though hardly an easy one. In fact, so hard that it may have no solution, in practice or in principle. So hard as not only to resist science, but to defy imagination. So hard that we cannot envision how it might possibly be solved. He turned to Galileo and went on as if to explain. Maybe one day we'll know, to the last exacting detail, how the brain spins its wheels. But this will give no traction to climb the peak of consciousness. Take memory, continued Alturi. To understand completely where memories are stored and how will be quite intricate. You can be sure of that, but it's conceivable. There is no lurking mystery, and it's being done. Indeed, machines can do it too. Machines that are the progeny of prototypes I had built myself. Similarly, said Alturi, we may be in awe at how the brain controls the refined sequence of motions it needs to play an instrument. We may be in awe at how it strings together sounds to make its words, and words to make its sentences. But I can prove to you, it's merely a matter of logic. Every such feat can be reduced to a series of simple steps, and if it can thus be reduced, then a machine can execute it. Take the action by which you grasp an apple and bring it to your mouth to take a bite, whatever your reasons for doing so, said Alturi. The programming of the motor sequence, the perfect coordination among the various limbs, the extraordinary control of forces brought into play by dozens of different muscles, the compensatory adjustments of posture, these are remarkably complicated feats. However, they are fully within the reach of a machine. Nothing is mysterious or unfathomable. The brain, this enchanted loom of a billion wires, can certainly house such a machine. Once we have figured out the mechanisms, there will be nothing left to explain. Likewise, continued Alturi, we may wonder how the brain can intercept mere flutters in the air and extract words and sentences out of them. Think how a foreign language sounds before you understand it. One long stream of clatter, with no beginning and no end. Yet the brain soon learns to parse words, one neatly separated from the other, and attaches a meaning to each of them. Or remember what you are told. The brain can recognize an object even though its shape may change depending on our point of view. It can recognize the color of an object even though the light in the room might be the warm light of sunset or the cold light of lightning. These are all remarkable feats, but there is nothing mysterious about them. Indeed, a machine can be built to do just as well as we do. A machine that can recognize objects, identify each color, recognize red or blue every time we do. It is merely a matter of having the machine go through the right series of computations. Certainly, the visual parts of our brain must contain such a machine. How else would the brain do it? But then, there's the rub, said Alciuri, as Frick had said, and paused for a while. You see, said Alciuri, even if we understood completely the mechanisms for distinguishing among the colors, down to the most niggling detail, we would still fail to understand why, alongside the nerve cells in the visual parts of the brain which slavishly perform their task, the task of distinguishing among colors, and use those distinctions to guide our behavior, why alongside all of this there should also exist a conscious experience of color, an eye who sees in front of himself vividly a red apple or a blue sky. No matter how I program the machine, what steps I force it to follow, I cannot see how it could see the same way I see, said Alciuri. It could perhaps behave like me, but I just cannot see how it would experience anything at all. And he smiled again, faintly. Then he showed Galileo a letter he had received from a famous brain scientist. I turn my gaze skyward. I see the flattened dome of the sky, and the sun's brilliant disk and 100 other visible things underneath it. What are the steps which bring this about? A pencil of light from the sun enters the eye and is focused there on the retina. It gives rise to a change, which in turn travels to the nerve layer at the top of the brain. The whole chain of these events, from the sun to the top of my brain, is physical. Each step is an electrical reaction. But now there succeeds a change wholly unlike any that led up to it, and wholly inexplicable by us. A visual scene presents itself to the mind. I see the dome of the sky and the sun in it, and 100 other visual things besides. In fact, I perceive a picture of the world around me. This is the enigma of consciousness, said Alciuri. Notes. The picture is of Alan Turing, who formalized the notion of computation by conceiving the Turing machine, a thought experiment, and developed the idea of the universal computer, which he then helped to build. During World War II, Turing worked at breaking the German codes and was able to unscramble that of the powerful Enigma machine. He was convicted of gross indecency after admitting to a sexual relationship with a man and was required to undergo hormone therapy. 2 years later he committed suicide by eating an apple laced with cyanide. The quote at the end is from Charles Sherrington, a neurophysiologist who discussed consciousness in Man on His Nature, Cambridge University Press, 1951, and compared the brain to an enchanted loom.